Hi, my name is Alex Applebaum. I am with product management. And a little bit about myself. I started out as an escalations engineer in professional services, and then I did a little on-site resident engineering at a major in Redmond, and then I did some field systems engineering out in the field, and now I'm back in PM. So I've been at F5 for a long time. So I know all the skeletons and all the power and all the et cetera, et cetera. So I'm not the last session, right? No, there's one more. Okay, because getting the last session is always the best. Okay. So what we're going to talk about is a little bit about so getting out in front of providing security strategy. Some things we're going to talk about is providing traditional shared services and how they kind of manifest themselves in cloud, as well as some kind of value add iterations that happen in cloud, like platform onboarding and platform provisioning services. Not necessarily in the direct, F5 scheme, but complementary. And so, we talk to a lot of customers, so we hear a lot of the big initial challenges to cloud adoption and how they really want to harness it, et cetera. And so it's kind of a good overview of what the challenges are to adopting cloud. So as you all know, I'm sure everyone here is knee deep into at least one cloud. If you haven't, there's a good chance to actually measure twice and cut once. But a lot of you are in there already, and then many of you are, as you saw in the speaker keynote, even in two at this point. So what typically happened, a little bit of history, as everyone knows, is you get a line of business, they go out and they start harnessing the cloud, they start deploying services, it becomes a success, then you start getting the herd, and you start scaling organically and more horizontally. So these kind of deployments maybe aren't as homogeneous as you'd like, right? They look a little like a snowflake, right? But at the end is what happens inevitably as things mature is just like kind of in code, right? Where you start to want to reuse, recycle, right? And you encapsulate that into a function or a class. Same things happens with services. So what inevitably happens is they start consolidating, aggregating these services into something like a shared services VPC. Well, it looks a lot similar to what we're used to, right? Like a DMZ, the analog is pretty close in like an enterprise architecture. So, replicated services, they don't really say what those are, but that looks familiar, right? So, one of the things is to try to enable lines of business to harness their, to really focus on their business logic. And as infrastructure providers, we want to enable that as much as possible. So this is back to, measure twice, cut once. If you haven't already, kind of measured twice, cut once, and you haven't gone into cloud, it's a really good chance to do a lot of research, right? And really get your architecture right. Because once you're in there, it's a lot harder to re-architect. So your cloud SAs that you're dealing with, they'll have a lot of these types of architectures, but there's a lot of caveats and a lot of sharp edges, and we've seen customers trying to take advantage of this, standardization. But little things will get you. The devil's always in the details. One of the things is these pure VPCs, and you have to do careful subnet planning, just like you would do on-prem, because they can't have overlapping networks. And the list of caveats is kind of long, so it's a good chance to, before you kind of start stamping out this type of shared services architecture, which does have a lot of compelling value, you just have to do your homework first, from what it sounds like. And so what does that look like with F5? Well, as you saw, application proxies, some of these services are the familiar things that you've always had. It's just they happen to be virtual, right? And so the customers started out deploying our services up into the shared services network. And of course, as things mature, like, hey, we got this great service, but hey, we need to talk to this other, service, and that happens to be on-prem. And so everything's a service mesh at this point, right? You have these services need to talk to these services, and these services need to talk to these services, and inevitably everything's talking over the network that needs to talk to each other. So there's a lot of stringing together, and as infrastructure providers, we tend to want to like gate things off and have a perimeter, because app developers, as much as they love to write secure code, and we trust them, and many of them do, things happen, right? So, we love network security, application security, layered security. So you want to try to give guardrails. Amazon has things called guardrails, not gates. We'll talk about that later. But one of the things we'll talk about is, well, how do we provide this kind of guidance? And so there's a couple. What happens is inevitably you get infrastructure sprawl. How many of you guys are running Kubernetes right now? Okay. How many have your VMware? Okay. How many of you dabbled in OpenShift? Okay. Are they running these on-prem or off-prem? On-prem, right? So that kind of looks like, on-prem as infrastructure providers, you want to provide these PaaSes. So you're taking on, app owners just want to deploy their app, right? They don't want to deploy the platform. They don't want to maintain the platform. They did it when they could, but they're like, all right, well, now I just want you to take over it, like hand over the, pump and dump. So, we as infrastructure providers are in charge of kind of providing all these different stacks and then gluing together these stacks. And so there's inevitably a lot of duct tape and gluing and things that you want to consolidate and provide. So what is the shared services? So another architecture regarding this is customers wanted to provide the cloud as a high-speed kind of back-end, right? They want to give their app owners or line of business access to all these great resources, but they still wanted centralized control. Because security kind of makes sense centralized, right? You have a brain. The moment you start putting data far away, you get latency. So there's a whole co-locating data challenge. So, security services lend themselves to be centralized. So one of the things is they've centralized in the colo. They may not want build out another data center, but they want to front end these backends. And if you're just going cloud native, what do these services look like? Well, they typically, when you move to the cloud, you kind of start with the analogs that So I deploy a pair or cluster, and I add multiple services to that, and I kind of own the shared infrastructure. So this is a multi-service, multi-tenant, but then you may get like a gold customer, compared to a bronze customer that may lend themselves to, hey, they need a dedicated service. So the thing about virtualization is it's really easy to, provision a new service, right? So why not just give them their own small blast zone and their own we kind of did this with VCMP, right? So if you have a big Viprion chassis and this customer is really afraid of upgrading, need to upgrade because of this or whatnot, and you don't want to compromise all the other customers, so you put them in their own VE, right? So VE is kind of started out as a nice encapsulation for a tenant, right? A certain blast zone. Well, the same thing happens in cloud. It's just easier to provision, right? You can just deploy multiple VEs. Of course, like anything, when you go distributed, you get a little bit of sprawl action and a management problem, but it does lend itself very nicely to producing smaller blast zones and dedicated services. And so what does that kind of look like? You kind of see this a lot per service or per app. We had a good discussion on the 101 if you were here about what per app was. We really probably should have called it per service because app is kind of an overloaded term. But per service basically meaning like if you think of Amazon.com, you think of that being one app, but it's really consists of thousands of microservices. So you need a load balancer for each one of those microservices, right? So that's really one service, one DNS name. So think about the per service as that one kind of application service, not necessarily 15 services that equal the app, right? So the per app is really per service. So, you may have started out with multiple multi-service, multi-tenant, but then, it may start splitting off and dedicating services to a high-tier dedicated, high-tier customer. And then you start taking advantage of other cloudy kind of optimizations like autoscale. Hey, this service tier, we want to dedicate, a little bit more services to it and kind of take advantage of some of the cloud architectures. So, shared services, the runtime and may look a little bit different, right? But it's still the same services, but it's just the implementation is kind of changing. So we see customers doing just lots of stamps for individual services. And then Big IQ will come in and help with the fleet management and application of that. And that has a good RBAC tier that if you want to, as an infrastructure provider, put that in front, and then you can give the app owner, direct access to the API. This is more of, when we talk about TMOS, is kind of the per app, per owner, kind of like Nginx HA proxy. There's not a lot of RBAC to it, but you can deploy the big IPs kind of in a per app, per service model. Okay, so obviously one of the big core security features we have is very popular in cloud is the WAF, which is kind of best in breed, so people want to leverage that and deploy that. So how do we give the line of business owners, you want to make it compelling, you want to, as infrastructure providers, provide these services, right? And not be dictatorial about it, but like, hey, we have these great services, but the app owner says, oh, well, I write the most secure code, I don't need that. Or how do you make it compelling to them to actually adopt these, right? So one is reduce the friction. So one of the friction things was, hey, all you have to do is, we can deploy on the side, right? And you just point to us, and then you can have everything route through it. If you don't like it, just like the one-arm config, one-arm architecture, you can point back to your app. But hey, it's out there, and you should really go through this. But so if their service is behind like another load balance service, and all they have is an IP or like a DNS name, in the case of like ELB, Amazon, you can point your pool to that, right? And it's low friction, low insertion friction, and bam, you're behind a WAF. And then if they're not in front of that, we also have service discovery options. That's what I'm going to be demoing later, where we use tags to discover the services. So you don't have to automate anything. You don't have to like change pool members and IPs and track all that. It just automatically discovers them for you. Okay, and then a little bit about, as you all know, we have a bunch of logging profiles that you can standardize on. But one of the things is that we are kind of looking into is if you're like a one-stop, one cloud type of customer, we are building more native integrations in each one of these kind of deployments. So we have another logging IApp that logs to S3, right? So, and then another logging IApp that logs to OMS. So if not necessarily trying to abstract your services, you can just, we're building more and more native integrations into each stack. Monitoring and alerting. Well, one of the cool things, and I always love, is when I get the alert, because I'm not perfect, I leave things on. I get that alert from IT that says, hey, you left this thing on, and it's costing us a bunch of money. So like, how do you provide as infrastructure people like this kind of complementary supportive services to your lines of business? And so you get one that, hey, your keys are too old. I kind of enjoy these friendly reminders, right? So that's what security is not necessarily, hey, I'm not letting you go to cloud. It's more like, hey, you're going to go to cloud, but I'm going to, do our best to actually make sure that your experience and that you're falling into, corporate best practices and kind of a friendly reminder, kind of nudging you on the way. And there's all sorts of like cool tools. I put a couple up here, and we have a lot of cool partners and vendors that kind of specialize in the kind of auditing and trailing and alerting kind of space. But even, for example, like our dev, our app teams wrote this kind of neat plugin to send a friendly reminder. If you get an AWS guard duty alert, they send it to the teams, right? So it's just a lot of these, you're seeing a lot of this type of security services kind of pop up. Not necessarily hey, you've been blocked or whatnot, but more of, hey, remember your keys are old, or remember your instances, are you sure you want them running, or have you changed your key? All these type of complementary services are kind of showing up. Okay, so the next thing is infrastructure provisioning. So we talk about DevOps and PlatSec, SecOps, and all this type of stuff. But in the end, we got to remember that the app owner, really, all they want is an API, right? They just want an API to hit, and our job is to kind of stand up that API. And so how do we, we talk to a lot of customers. They're all like, oh, I want to build this, self-service portal, or I, abstract the things that I want to, create the self-service portal to deploy all the things that I know that app developers do. And what we've seen from talking to customers, and we go to a lot of these conferences, it's almost an impossible feat, right? Your self-service portal is never going to provide the coverage that the full PaaS is, right? That's just, Mono in general is always a subset of what you're trying, your abstraction is always a subset of the full feature set. And no one can actually to provide that 100% abstraction to all the different services of the cloud. So, inevitably, like, oh, I built this generic abstraction where I onboard them to the AWS, I create a VPC, and I let them create ELBs and all that kind of stuff. And then, they start. And then now I did it to Google, but you start limiting the amount of the PaaS that they can actually access. And so we've kind of seen that effort kind of translate into, well, I'm not necessarily going to build the abstraction for all the PaaS. I'm just going to get them all started. So I'm going to make sure that they get an account. I'm going to make sure that they get set up with the right network architecture, the right keying policy, everything, all the kind of supporting services, and then let them go free, right? Go set forth. And so the end, if you are providing services in the end, it goes from, if you're app owner, you don't want a ticket. You don't want to create a ticket with ServiceNow, no offense, but you want an API to hit, right? You want an API and some credentials, and that's how they want to interact and consume any services that infrastructure people are providing, whether it be a PaaS or a WAF or whatnot. So how that kind of is manifested is, before we'd provide golden images, right, with the hardened Linux OS, and now when it gets to cloud, you're kind of, a lot of the artifacts that we're producing are not images, they're extending to infrastructure as code. So, hey, I'm going to give you some golden templates now, right? This is our best practices encapsulated. You guys have a lot of really good, strong domain knowledge that app owners don't, right? And they don't want that. And so they just want to get going. And so they don't want to necessarily know how NAT gateways work and a lot of this other stuff works. But if they're going to be working in the IIS kind of space, you want to set them up for success, right? So you set them up with the right network, the right bastion host, with the right golden image, with the right policy, and they're free to go in the end. So that's what we've seen a lot, like the last reInvent, they talked a lot about that. So it's more of a, set them up with all these best practices. AWS has this thing called Service Catalog, where you kind of write all your CloudFormation templates, and you customize them and put all your best practices in them, and then you put them in that self-service catalog, and their customers can consume them. And so when you're doing these and you're creating these custom images and these custom infrastructure as code, where you get your chance to introduce all your good security knowledge and best practices, are we making them in the most modular, reusable form? So, typical infrastructure stack looks like you have a network stack, right, with all everything network related, NATs and whatnot, routing and route tables and security rules. And you have a bastion host stack so they can log on. So a lot of times that's Linux or whatnot. And then you can obviously introduce the proxy WAF stack. And then you may have, God forbid if they want to take on managing the lifecycle of PaaS, you may have a stack with deploys Kubernetes or OpenShift or whatnot. And then, of course, the application stack, that's more them. But you may have hey, this is a sample web stack that we think is kind of deployed in what we think is a secure fashion, right? And that's how it looks. Visually, that's kind of what it looks like in the stacks in AWS, but it's the same in every cloud. Okay, so like a couple of things in these infrastructure as code things, take advantage of all the kind of neat features that each one of these providers have. Like AWS has a cool thing called protect your stack. So network stacks, really easy to delete, right? So enable protection on those. So this is a chance that you introduce your best practices. Security IAM rule, this is kind of the obvious low-hanging fruit. Make sure that your ACLs are right, that there's a tool that talked about CFN NAG that somebody at re:Invent was talking about. They built solely to kind of audit what your templates look like. So after you finish customizing them, make sure that they adhere to your corporate policies. And then Netflix always has cool stuff. They're obviously the thought leader in cloud. They've been doing it the longest and doing it at scale. So they always have cool stuff. That's one feed you should always follow. I always follow. And so on to the demo. I'm leaving more time for question and answers. So the demo is kind of your typical, any questions right now before I go to the demo? I talk fast and I want to get to the demo. No? Okay. All right, so the demo is the typical hello world source to prod. You've probably seen it 4 times. The spin I'm doing it is I'm introducing the big IP as the final step. So here we go. So it kind of looks like this. I have an Amazon stack, an Azure stack, and a Google stack. I'm going to update the code in GitHub. It's going to build a container, and it's going to deploy that container in a VM or directly to Kubernetes using Spinnaker. So Spinnaker is Netflix's tool that they use for continuous deployment. So how many of you heard of Spinnaker? Okay. So they've been doing it the longest. So they have, they've operationalized a lot of the cloud lifecycle. And one of the cool parts of this tool is it helps facilitate the immutable lifecycle. Instead of actively touching and managing things, in cloud you do a lot of declaration and you don't touch it afterwards. So instead of deploying servers and then upgrading those servers in place, you just build a new one and deploy that. You want to make a change, you got a security patch, you build a new one and deploy that, and you pave and nuke. So it makes a lot of sense for the application tier. The network tier, kind of don't pave and nuke. And the data tier, database compute you can, but the actual data itself is kind of hard to pave and nuke. But the application tier, any application tier lends itself to this, and it's safer because your apps don't have to dynamically build on the fly and worry about it. So it's kind of the immutable lifecycle. You hear that a lot when you go in cloud. Okay, so the components are, we deploy the infrastructure with templates. Everything's a template these days. We like declarative interfaces. AS3 is the declarative interface for Big IP, CloudFormation, Google templates, Azure ARM templates, so the declarative interface for the cloud. Manifests and Helm charts, so the declarative interface for Kubernetes. So we just like to deploy templates everywhere. So we're going to deploy our infrastructure with infrastructure as code. We deploy them as networks, Bastion host and ADC tier with templates. And then we'll go and deploy, we'll make a change to our code in GitHub, and then we'll build a Docker container, and then we'll use Spinnaker to deploy that in a blue-green kind of lifecycle. And Spinnaker kind of, what it does is, I'll talk about it here. You change code, you push it to GitHub. GitHub, once it's done, sends a webhook, it notices a change in GitHub, sends a webhook to Docker, the service. Docker has a cool little free feature where they'll build the Docker container for you. You just send it the Docker file. And then once Docker is done building, it will go send a webhook to our CD tool. So it's a CI, CD, and CD, the last part is continuous deployment. So Docker Hub will send a webhook to Spinnaker, and that will trigger its pipeline. We'll go make a VM, And I'm just cheating and putting it, the only part of baking a VM is putting it in a container, but typically you would take your artifacts that you create, your RPM and deb packages, and bundle them up in a container, and that's your web server. I'm just cheating by putting it in a container. But the idea is you build this server immutably, and you don't touch it afterwards, you just deploy it. And then finally, you go deploy that in an auto-scale group, right? In each one of the clouds, they all have the same kind of notions. And then the last step is, hey, super easy. All you need is a little REST call, right, to update the big IP, the WAF tier, and says, oh, now I'm pointing to this autoscale group and that autoscale group. If the application was behind a VIP, you wouldn't have to do anything. But I'm just showing you, there's very low friction in order to provide this service in front of another service, part of our microservices mesh. And this is a little bit more in detail, but in general, this is kind of high-level visual. This doesn't exactly look like it, but we have our trigger. Basically, what starts this pipeline. In this case, it's going to be a webhook from Docker Hub, and then we're going to go make some images using Packer. So Packer is I have a lot of tools in this, so it's kind of hard to summarize. But Packer goes and makes the VM, right? That's kind of the Docker file for the VMs, by ideal, the product manager for virtual edition. So that's the kind of domain that we're building. And then we're going to go deploy it in some autoscale groups. And then we're going to update the big IP tier so it's pointing to the new autoscale group. Everything makes sense? Okay. So right now we have, I'll start from the stack. So we have a big IP deployed in the CloudFormation template. So it's an autoscale group. So it's a ADC service tier. Then we have our WAF service tier in big IP WAF service tier deployed in Azure via Stack. Right? And then we have our big IP WAF tier in Google deployed via a Stack. So it's called the Google Deployment Manager. So you can see over here, this Stack. Little disclaimer, this is a prototype template on the Google side because we're just a little bit behind on that side. So this is the network tier and the infrastructure tier deployed via templates. And then here's the app. Of course, my Hello World app, not very exciting. This is what it looks like. We're here in Boston. And then I'm going to make a change to that. So right now, I'm logged on my local host. And I'm going to change the color. Blue, green, literal, I know. You've seen this 1,000 times, but this is with WAF. So this is what it looks like from developer side. All right, save that. God bless. All right, so that's on my local host. I'm going to push that out to GitHub. I like it, looks good. I'm going to commit it. I got to do one more thing so Docker can build an image for it. I'm going to tag it. And my last tag was, when was my last tag? 245. All right, so this is a new version. I'm going to call this 246. All right, now I'm going to push it out to GitHub. Okay, so now it goes to GitHub. All right, 246 shows. Now, this should trigger a build in Docker Hub. So this is going to take the file in here. Here's my Docker file. It's going to take this file and build my application, it's a little Node web app in a container. So it's building here. This is the longest, kind of most painful part of the demo because it's a free shared service. I can't complain how long it takes. So it puts it in a queue. Sometimes it takes immediately. Sometimes if there's a lot of people, it takes a couple minutes. Typically you have your own build service. The clouds have their own kind of private build service that does the same thing. That's a lot quicker. Or you can build it locally on your build server, your Jenkins server or whatnot. But I like to use free things for demos, so. All right, it's queued. And this is one of those days where it's taking a little bit longer instead of building. So any questions so far? What's going to happen next, Gino? Did I make that clear? After this builds, what's it going to do? No one will volunteer. Yeah. Yeah. Yeah, so the Docker Hub is going to send a webhook to Spinnaker. Right. And Spinnaker is going to start building the VM. Ah, finally. All right, so this should take like a minute now. And this is like pretty much the velocity of pushing new code to cloud. This is a very small web app and a very small VM, right? This is the fastest you can possibly do, like 10 minutes. When you get into containers, you can push out code changes and a lot quicker. Okay. Docker Hub must know I'm doing a demo right now, because usually I did not call them today. So I'm just starting to kick this off, and then I'll go a little bit more Q&A afterwards. I just want to get to the building of the VM part, and then that will go, and I'll kind of come back to it eventually. Okay. So now, this sends a webhook to Spinnaker. Spinnaker will start the pipeline, right? And this is where it's going to start baking the VM, right? So it uses Packer and it launches Packer basically is used to create VM. So it launches a VM, it does all the stuff, the packaging, the building, installing all the packages, RPMs, the deb packages, whatever it does to make your application, right, your runtime. And then it snapshots it and makes an image out of it. And then you use that image to deploy into a autoscale group. So that's the VM that you make. So it's just a dynamic, so you're creating images nonstop, and then you use those as your artifacts that you're deploying. And this is kind of the cloud wars right here. I'm gonna show who goes the fastest, right? So they're both going, and you'll see one's predictably very, very slow compared to the other ones. They're all great, they all have their strengths and weaknesses, but it's just funny to see some of the difference of speeds. They're both doing exactly the same thing. So now we're making a VM. So this Spinnaker tool is using Packer in launching VMs in each of the clouds, and then it uses a Packer file, which looks a lot like a Docker file, to do that, but it's actually, using APIs. The Spinnaker server is using APIs to each of the clouds to do this. Okay, so this takes, if you look, I'll show the last two, just to give you an idea. This takes about 4 minutes in AWS, 3 minutes in Google, a little bit longer in Azure. So we have a little time to do Q&A. But while this is building, it's the same process in each one of them. It's cool, you can see it, hopefully it's building. I promise you there's lots of successes before, so if this does break, it's just demo, gremlins. It was all green before. Okay. So this is just trying to show you a little bit of, from the application owner's perspective, of like a little bit of a cloudy lifecycle where they deploy immediately and update. This tool is a nice abstraction, right? That kind of deals with autoscale groups and whatnot. So it's kind of very opinionated, very tuned to the mutable lifecycle and Netflix's lifecycle. A very cool abstraction tool. Doesn't do Lambda, you know what I mean? So it's any kind of tool will date itself eventually. But it isn't, as far as dealing with IIS, this is the kind of the taken to the end of the road. Like this is IIS optimized as much as possible, right? All right, so this went and created a VM, an image, right? So if I go look at the details, it created this AMI, a new VM. So if we go here, EC2, instances, AMIs. So it created an image that I will use. What is it? Demo app. So you can see I've created a bunch. And then so it just creates the images that you use in the autoscale groups. So there's every change, a new build, right? You're not config managing anything. You're just building a new thing, and you don't touch it afterwards. Back to this. Right, see one guy going a little bit slower. Okay, so this is actually, now it's got the image, now it's deploying it. So it's creating another autoscale group. See, it's deleting this one. So there's like a bunch of different strategies. So it just deployed this autoscale group, and it's going to delete the old one, so it keeps two. Because Netflix has this kind of, they call it the red-black strategy, or blue, it's really blue-green, but it's, their colors are obviously red-black. But so it deleted that one, so now this is deployed, right? Same thing happened over here. right? So it's created, incremented, right? And we're going to use the name of this group to point the big IP to using service discovery. So now it's updating the big IP. I should have showed you, we're all blue. We're at AWS, Azure, GCE. They're pointing to big IPs in these clouds. This is GTM. And if you go to the big IP, we are querying the pool members for the tag. See, we're using the autoscale group name. And we're saying, oh, now point to this pool. So now the big IP is like switched and said now we're pointing to this new group of new servers, the green servers. So we have this in all the different clouds. Right? So we're looking for this. This is getting automatically updated. And in Google, we're looking for, Spinnaker calls it Spinnaker server group, and then we're tagging it. It's named 39. So now the big IP is now pointing to the green servers. So technically, if I look at here, right, this should be done. So AWS, if I go to AWS, it should be updated. So AWS should technically be green. Okay, so we deployed a new version of the app, all bundled in a new VM. Right there, and now this one is still going. And then Google should be done. So if I go to Google, hopefully my Google one is done. All right, and you're green. Now if I hit Azure, you're still going to be blue. Yeah, you're still blue. But the idea is, sitting behind a WAF, stupid attack, not real, but bin, RM. What? What the? No. All right, sorry. Of course, anyway, so that's behind a WAF, right? With very little friction to deployment. And let's see, this is taking a really long time in Azure. Let's see how long the other one took. All right, that's still in line. But one of the cool things about this, just so you can kind of see, is this is not a typical deployment. This is straight to prod, but typically you deploy into a staging environment, right? Then they'd run some tests on it. I just don't have that much time for a demo. But you'd have a duplicate staging environment, So you build the same VM, you deploy that to the staging environment, you do a test, some smoke tests or canary tests on that, and then you deploy it to prod, right? So I just didn't want to deploy. It takes long enough as it is. So, but and some of the cool stuff of Spinnaker is you edit. And they've added, there's a lot of nuance and granular functionality that's not just pave and nuke, right? It's not just as easy as declare. There's a lot of nuance in there. So, they have all sorts of fun strategies that they build into this, right? So they have like Highlander, which just, instead of keeping a blue and a green autoscale group, they just, that costs money because you have duplicates, they just nuke and pave. And that's good for like dev and test. But they have all these different strategies. They have all these different pipelines. Right, so you can introduce like manual gates once you deploy to stage and say, all right, well, I got the manager approval, everything looks good in the stage, push the button, please don't fire me. They have, what is it called? Manual judgment right there. That's what I was just explaining. But the last part, which I use for the big IP, is just run a script, right? And that script is update the big IP with a JSON blob. Done. That's kind of how it fits into the continuous deployment pipeline. That all make sense? All right, cool. And then all right, we're almost done. And hopefully in maybe a minute, we'll be done with Azure, and then I can breathe. Did you guys go to the 101 or 201? Y'all, okay. I also highly recommend, of ones to go to, is the security team has lots of cool stuff they do at the WAF. I'm just showing basic WAF, but they have lots of interesting, Yossi has a good one where they're doing CI/CD with WAF policies. So you can kind of start adopting more of the application lifecycle, even treating your infrastructure with that kind of same methodology. The Big IQ one where you deploy virtual editions, it will offload that kind of workload and kind of take care of your fleet management. Yeah, but anyway, there's lots of good ones that I'd recommend. Okay. And this, almost there. I should actually show you it. That'd probably be helpful. So this script to update the big IP, I'm just using an Ansible playbook, right? And I'm updating the app with the new tag. And if you look how you configure it, you basically just take the output of one of the, so the Spinnaker has this kind of context of stages. And so you're just taking the output of one of the stages and you're shoving it into the payload, the JSON payload that you're sending to the big IP and interpolating it. So to get the value of the autoscale group that I just deployed, it's just called stage deploy in US West 2, and I grab the autoscale group out of that. And so that translates to the tag that I'm actually updating the big IP with. And this could be, if it's AS3, applications as a service 3, just whatever client does a JSON payload. I have some Terraform examples too. Whatever your build server has, right? Whatever tool it uses to make a JSON call, almost anyone does. You can use that as part of your script. Okay, does that make sense? All right.
See, the sequence is important when.
All right, so this should be done. Oh, it's 1 second, and then technically, if I go, I'll have a sense of closure. All right, updated. Okay, this isn't a real app. Obviously, data tier is impossible to make multi-cloud, but just showing you a similar runtime can be run in each cloud. No one really runs the same app on each cloud. Usually what happens is I do one service over here, because it's optimized, I do another service over there. But the data tier, the data gravity doesn't really make it feasible to run the same app in all different platforms, right? But just showing you the homogeny of running services that we can provide. Okay, sorry, who asked the last question? I forgot. You asked. Did you ask?
I was going to ask, but.
Okay, I got cards. I need to give cards out. No. Okay, go ahead.
So basically, you wait till the tagged virtual machine or deployed machine come up, and then you update their file with that tag so that you can monitor afterwards. Is that the sequence is important?
Yeah, because you want to wait till it's deployed.
So that the old version keeps running at that time when you're nuking it, before nuking it, kind of thing.
That's a good question. I didn't do a good job of articulating that. Oh, that does not look green on that thing. Okay, so what happens is basically it deploys an autoscale group with blue and green, right? So if you go to this autoscale group and you go to the instances, you want to wait till that's deployed, and all these instances are tagged. Like this is an instance in that group. They're all tagged with a bunch of tags. So when that version of that app is deployed in the autoscale group, then you upgrade the tag definition on the big IP. Google has a lot of cool stuff on everything's by tag. So all their ACLs or firewall rules are you just tag a bunch of images and you create a firewall rule dynamically. Same thing with routes. You just tag things and it creates the automatic route. So it's very, in containers, everything's a tag. Service discovery via tag and DNS. So it's just a way to, discover services. And
What are you using for the tag?
for the VMs?
Yeah. Because you said you had that key role, right?
Yeah, so technically you could, before you switch over, you can run all sorts of canary tests. That's been part of that pipeline. Yeah, before you do that, for sure.
So are you using ASM and ASM there as an app?
Yeah.
Amazon has their own app, right? So is our Applebaum compatible with their app?
No, it's just deployed in front as a separate service. So yeah, they have their own. It's not integrated. That we actually have WAF rules in their WAF tier, but this is just the standalone ASM that you're used to.